So, ionic bonds are found in, you guessed it, ionic compounds. And ionic compounds are those compounds that are formed between metals and non-metals. And the metals in ionic compounds are always found in the form of cations, which are a result of the loss of electrons, and anions and non-metals are always found in the form of anions, which are formed as a result of the gain of electrons. So a good question is where do those electrons get lost to that the metals lose, and where do the electrons that the non-metals gain come from? Well, what you can quickly realize is that if there is a transfer of electrons from one atom to another, this would solve this problem. And in particular, if there was a transfer of electrons from metals to non-metals. So in ionic compounds, metals lose electrons to non-metals. This results in the metals forming cations and the non-metals forming anions. And what do cations and anions do? They attract one another, and that's the formation of an ionic bond. So the first thing we need to recognize is why do atoms lose or gain electrons, and how many electrons are they going to lose or gain? So we know that the least likely to react elements are in group 8A of the periodic table. These are the noble gases. And all of these elements, helium through radon, they all have a complete outer shell that has either a completely filled up S subshell in the case of helium, or a completely filled S and P outer subshell in the case of everything else from neon through to radon. So you can see that illustrated here. Most of them have this completely filled S and P outer subshell with 8 electrons in it, except for helium that just has a completely filled 1s. So what we can conclude is that the most stable electron configuration, the one which is least likely to change, is the one in which the atom has a completely full outer S and P subshell. That is, it has a kind of an electron configuration that ends like this, ns2, np6, where N indicates the highest shell. So what we're going to observe is that atoms will keep losing or gaining electrons until they have this configuration, at which point they will become stable and they'll stop reacting. So if an atom doesn't have what we call a complete octet with 8 electrons in it like this, then it will try and gain it through forming chemical bonds, and then once it's got that stable configuration, it'll become unreactive and it'll stop reacting any further. So this is summarized in what we call the octet rule. It says that in forming chemical compounds, atoms of elements transfer or share electrons so as to obtain a noble gas configuration of the atoms involved. And the transfer of electrons is what we call ionic bonding, and that's what we're going to be studying in this section. So we know that atoms have an equal number of protons and electrons, and we can get this number from the periodic table. It's called the atomic number. Because the number of electrons and protons is equal, atoms have no net electrical charge. Now, if an atom loses some electrons or gains some electrons, it'll form an ion. So when an atom loses one or more electrons, it forms a cation. Metals and hydrogen form cations. Now, hydrogen is actually classified as a non-metal. We should be aware of that. So sodium tends to lose one electron, forming a single positive ion. Okay, Now, when an atom gains one or more electrons, it forms a negatively charged anion, and it is the nonmetals that form anions. For example, chlorine atoms will gain one electron, forming a single negatively charged anion Cl-, and you can see that the number of the total charge on either side of my arrow here is -1, and that's important. Charge needs to balance on either side of an arrow like this. So electron loss to form a cation and electron gain to form an anion occur simultaneously via electron transfer. So if a sodium atom bangs into a chlorine atom, this is what's going to happen. Sodium likes to lose electrons. It has a low ionization energy, 1, and chlorine likes to gain electrons. So a sodium atom has electron configuration 1s2, 2s2, 2p6, 3s1. And a chlorine atom has electron configuration 1s2, 2s2, 2p6, 3s2, 3p5. So if a sodium atom loses one electron and transfers it to a chlorine atom, when it bangs into that chlorine atom, what happens? That electron goes over there. And so now the sodium atom, by losing that electron, has a noble gas configuration, and the chlorine atom, because it gained an electron, it also has a noble gas configuration. The only problem is that the sodium atom now has a positive charge. It's become a sodium ion. The chlorine atom now has a negative charge. It has become the chloride anion. And what do positives and negatives do? They stick to one another. So these guys have a noble gas configuration, but they are now bound to one another via what we call an ionic bond. So the transfer of electrons results in two things. Each of the atoms involved obtains a noble gas configuration and becomes chemically stable. It doesn't want to change anymore. However, those two atoms become stuck to one another via an ionic bond. So that's it. That's how ionic bonds and ionic compounds form. So electron loss by the metal and electron gain by the nonmetal occur concurrently. The atoms collide and there's a transfer of electrons. The ions that are formed as a result of electron transfer will be attracted to one another, and that's the origin of what we call the ionic bond. So the electron transfer results in the atoms becoming stuck to each other. Now we can use Lewis structures to illustrate how electrons are transferred to form ionic bonds. So here's the Lewis structure of a lithium atom. It's in group 1a, so it has 1 dot. Here's the Lewis structure of a chlorine atom. It's in group 7a, so it has 7 dots. And then the electrons always move from the metal to the non-metal. Now when we're using Lewis symbols to illustrate how electrons are transferred, we always put the metal on the left and the non-metal on the right. The transfer results in the formation of the lithium ion, lithium +1 ion, and the chloride -1 anion. So we indicated that here, and by convention we normally put the symbol of the atom in parentheses when it's present in the ionic form, and then the charge goes outside. And then we drew a second arrow and we just write the formula of the compound as we conventionally do: metal on the left, non-metal on the right. You'll notice in every case that when you do this, that the metal ends up with no dots, it loses everything in its valence shell, and the non-metal always ends up with 8 dots. There we go. Okay. So when ionic compound forms, the metal atom will lose all of its outer shell electrons. You see it has none there. And then the non-metal atom will complete its outer shell and it'll end up with 8 valence electrons. As I mentioned, we always write the metal ion on the left as it appears on the periodic table, and the non-metal on the right. Now something to be aware of is you may require more than one of the ions. So for example, if I have magnesium combining with chlorine. It's going to lose 1 electron, but that doesn't leave the metal with an empty valence shell, so we're going to need another chlorine. There we go. And then now that works. In this case, the magnesium will be 2+ because it lost 2 electrons, and then we've got 2 chlorines, each gained 1 electron, so they're -1. And the convention is when you have multiple of an atom or ion, you kind of tend to stack them vertically, just like that. Alright, so sometimes you need more than one of your anion or cation. Sometimes you need more than one of both your anion and cation. Okay, so there are no ALEX topics for this section, but I hope you found the video helpful. So yeah, if you have any difficulties with the content, please just reach out to me.